All right, welcome to the next talk. This is Kory Draughn. He's with the iRODS Consortium. You saw him a little bit yesterday. He's going to talk about, in more depth, the software we talked about yesterday, NFSRODS, which presents iRODS as NFSv4.1.
Okay. All right. Hey, everybody. So let's get started. So what is NFSRODS? It's a new iRODS client, and it presents iRODS as NFS 4.1. It also supports 4.0 and 3, but you really want to be using 4.1. It allows you to mount exposed iRODS collections via a NFS mount, and the software is open source, and you can find it. You can see it. Here's a GitHub repo, so if you want to check it out, you can do that now. Why is this important? So it presents iRODS as a standard POSIX file system, and it allows you to use all of your existing tools to basically access and manipulate iRODS. And with that, you get access to the policy layer. So all your policy is fired by making changes and manipulating things within this mount point. This is done through through support of NFSRODS, which is a open source Java project, which basically allows you to implement a single interface that allows you to expose another piece of software as a mount point within like Linux or Unix. And we have this package as Docker to make it as simple as possible so that you can deploy this. So that you only have to think about things like your configuration and like what port you want to expose this on. So as of today, we've released 0.8, and with that you get authentication and authorization, which I'll talk about later. So in the beginning, when we were first looking at implementing this thing, one of the things that we encountered was how do we translate how do we capture what users actually accessing the mount point? And one of the things that we knew was, after some time with NFSRODS, we knew that it had native support for Kerberos. So it was kind of an obvious answer to us at that time to let's give Kerberos a try. And so once we got that working, the good thing is that it did work once we figured it out and had enough time with it. And because of Kerberos, we had built-in authentication. The bad side of that is that deploying this thing was really complicated. It required anybody who's unfamiliar with Kerberos to get familiar with Kerberos. And they had even clients who wanted to use it, they needed to know at least KINIT or a few other Kerberos commands. Also, when it came to packaging, we ran into a situation where it was difficult to containerize Kerberos along with NFSRODS. So essentially our solution was we just scrapped that, we just scrapped it. And basically we simplified it all the way down to where now NFSRODS basically makes a lot of assumptions about where it's running. So essentially NFSRODS expects where it does not, it expects its environment to be secure. It does not, it just trusts the operating system. What it sees is, so it sees UIDs and GIDs and group IDs come in, and it expects, and it just assumes that these things are okay. It just trusts everything. So with NFS, the way it identifies users is through UID and GID. And so we had to figure out, so how do we make NFSRODS, how do we capture that information in these commands? And the way we did that is through the etc password and etc shadow files. So basically with Docker, because we're using Docker, you can mount these files within the container and say, here's my list of users. And so and this is necessary because for iRODS doesn't work with UIDs and GIDs, it works with names, usernames. So basically any users that you expect to use or be able to access this mount point, they have to be defined within the etc password and etc shadow file. And so one thing to keep, an important note about this is that users, if you have users that have root access, and they can just be anyone, so they can show up as Alice or Bob and do whatever they want. So you really want to make sure that the machine that the container is running on is locked down, okay? And so I guess just looking at this image down here, let's explain what's happening here. We have basically NFSRODS sits in the middle. It's, let's say we have some machine that's been hardened and it has NFSRODS running in a container here. And above it, in the little cloud here, we have maybe Active Directory or LDAP, and it's maybe producing something like, it's producing all of the users within the environment. And these are basically stored in etc password etc shadow file. And this file is basically synced amongst all the machines within the environment. So Alice over here at the enterprise VM, their UID is stored in the files that are provided through Active Directory and LDAP, as well as NFSRODS also has access to this. So when Alice accesses the mount point, NFSRODS sees the UID, and now NFSRODS can translate and resolve the UID to the actual name, which now we can work with in iRODS. So for the authorization model, this was one of the things, this was a little challenging, but I think we have something that works. So some key points is that collections within NFSRODS always appear as executable. This is necessary because in iRODS, if you share data objects and collections, maybe they are several collections deep, iRODS does not validate whether a user has access to the paths, to the collections and things leading up to the target collection, right? But Linux and Unix does. So it's necessary for collections and all these things to be executable. This allows users to traverse the tree with limited access. They can at least get to a target path without necessarily being able to see anything. Data objects are never executable. And another thing that's really important with this is that depending on who's accessing the mount point, permissions change. So what one user sees, another user will see something completely different when they try to go view this thing, because this NFSRODS is interpreting the iRODS permissions into Linux permissions as best it can. And this is kind of tricky because iRODS has a linear permission model, whereas that Linux and Unix do not. So just to explain the little chart down here at the bottom, the way, let's say you have a user that has own permissions on a data object or a collection. The way this would work is NFSRODS would see this and it will say, oh, this is an owner. So it maps the owner to the owner name and permissions bits in Linux land. And if you have a non-owner, then those permissions are mapped to world permissions. Okay? All right. So with this, we deployed this in a test environment to see what people's thoughts were about it. So what did we get? So what did we get right? People were happy with how simple it was to deploy this. They didn't they didn't need Kerberos or any extra things, or they didn't need anything else to be able to run this in their environment. It was easy to deploy. They were happy with the authentication model, and the permissions worked. So I didn't say this, but so one of the things is that we don't support groups at all in NFSRODS. Groups are just not supported. And when people encountered how we handled world permissions, they were a little surprised by this and just raised some eyebrows. And they kind of just led into the question of, can we have extended ACLs, right? Okay, so that's essentially the most important details about NFSRODS that you need to know. But so now we're going to talk about how this thing is deployed. So if you're going to the GitHub repo and you want to build this thing yourself, then this is the steps that it takes. So just some requirements. So you need iRODS 4.2, and you also need the update collection M-time rule engine plugin. NFSRODS is actually is the reason for this plugin even existing, because it turns out that NFS actually cares about the M-time of the directories and file objects. And so by having this rule engine plugin, this actually provides the capability for iRODS to detect when changes occur within collections and can update the M-time as things change. And the last requirement is simply Docker. So step 2, we build the image, and that's pretty common sense. I figure this is pretty common things, but just to clarify for people who don't know, basically we clone it, we go into the clone directory, and then we just run the build, we run Docker build, and we tag it with NFSRODS just for simplicity so that we can identify what the image name is. So here's all of the configuration for NFSRODS, and what we have is basically we have NFS server, iRODS client, and iRODS proxy admin account. So on the NFS server is a section that defines what are we exposing from the mount point, from the NFS server. In this case, like, you can define what port you want to listen to within the container. It's not that important as far as the port, but the most important parts of NFS server are iRODS mount point and the user information refresh time in minutes and file information refresh time in milliseconds. The iRODS mount point is the thing that you change, this is how you tell NFSRODS what collection to expose from the mount point. In this case, it's set to /temp zone, so this makes it possible for many users to share information and access different other people's shared objects and things within iRODS. User information refresh time in minutes is simply instructing NFSRODS how long should it hold onto the cache of users. So as users access the mount point, NFSRODS updates its cache and says anytime if they see the user again, if we have it, then we just use it it's a speed type thing. Same for file information refresh time in milliseconds. So it turns out that NFS4J loves to stat objects. It really loves, and that was one of the biggest performance hits for NFSRODS. But the way we got around this was to basically add a cache for stat information. And so right here we set it to 1 second, and that basically is enough to drastically improve the performance and speed of NFSRODS. iRODS client is essentially telling the embedded iRODS client within NFSRODS what server to access, right? And iRODS proxy admin account is simply this is simply the account that NFSRODS uses to do all of its work. So all of the operations within NFSRODS is done through an admin account. And okay, yeah, okay. So step 4, 5, and 6 are all about how do we launch it, mount it, and just 6 is simply an example of how to use it. But the most important thing here is step 4. If we look at this command, all this is saying is we want to launch NFSRODS as a daemon process, and we want to map port 3000 on the external side to the 2049 port that the actual NFSRODS server is listening on within the container. Then we also want to set up some volume mounts. We want to provide some links between the external environment and the actual container so that it knows so the NFSRODS knows where its configuration is, where the etc password and etc shadow files are. And then we just give it the image name that we want to run. Okay. And step 5, if you look closely, you'll see we have a line here that just tells us, like, this is the port that we want to actually mount on, because this is how we set the ports here. Okay, so I'm going to try to do a live demo of this, and hopefully everything works. It's going to be very simple. Okay. Okay, so this right here, so with the release of 0.8 today, you can actually do Docker pull iRODS / NFSRODS, and you can do the same thing that I'm doing right now. So here's the step 4 where we're doing the launch. It's basically the exact same things. In my environment, I have 2 users. I have myself and I have a user named John. And so we run this, and then we want to see the logs. Logs, NFSRODS. So now we can see iROD that the NFSRODS container is up and running. It even prints out lots of debug information so that you can actually see what's going on, along with the configuration that was actually read in. So that's up. And now here, I am going to mount you as Kory on port 3000. If we jump back, we can see, okay, it looks like everything worked. And so now we can go over here. We can look inside the mount point. We can see we have home trash. So we go a little bit deeper. And we can see here's...
You get tab completion?
Right, we get tab completion. So if we go in here, let's go into Kory. And, well, let's do this right here. Okay. So we can both see all the users and things right here. So one thing to note here is that Kory is actually a RODS admin, whereas that John is a RODS user. And this might look funny right now, but I'll explain what's happening here a little bit later. Essentially, so we can read and write files and things. So let's try that. Let's see. Let's echo. To right, and now we can listen, see that things are changing. Cat, and see that we can even do things like this. You can drop in and, you know, you can type things. Well, let's get rid of that. Let's say. And we got there, and we can cat again. And we can see that all those things work. And so we have, it even supports inheritance and follows inheritance within iRODS and all the permissions. So we have a shared directory here that I made earlier. And we're going to go inside here. And if we look at some of these permissions, let's go into Kory's home directory as John. So if we go in here and we try to ls in here, John can't see anything here because he doesn't have permission. But on the shared directory, if we were to do this, then he can, because I've shared this. John has, I think, write permissions here. So we do ILS-A shared. Then we can see John has write access to this directory, to this collection within iRODS, and NFSRODS does the right thing. Okay. So, yeah, I think that's good enough. We can come back to this later. All right. So back to the slides. So great, it worked. Everything works. So we should just use this for everything, right? Just point all your tools at NFSRODS and everything's good. All right. Well, of course not. There's always caveats. So one of the things is that NFSRODS is going to be slower than things like iCommands, right? Because we've added a new layer in between to do this. Caching also turns out to be a problem for NFSRODS as well. It turns out like we're doing caching for speed purposes, but it actually turns out that NFS itself is caching things as well. So going back to this thing, earlier I showed you that I told you John was a RODS user, whereas that Kory was a RODS admin, yet John could see he could see the same information that Kory could see. And this turns out to be because of how NFS works. It's caching file attributes and things and trying to keep things speedy. But there's some things that you can do to mitigate this, like you might want to consider using lookup cache equals none, which means basically it's going to force the NFSRODS server to constantly reevaluate reevaluate all the paths and things that it's about to present. Therefore, you keep things, it's more consistent, but it comes with a price of speed, right? If you just read the bullet points here, it's like information leakage is a possible thing, like with this. Okay, so what's the future plans for NFSRODS? So NFS has its own standardized ACL support, and so that's something we will be looking into to see if we can remedy the world permissions case, since that's something that was questionable to the people that we deployed this in their environment. It also enables support for groups. We also want to look into parallel transfer and unit testing. Right now we have run this against something called NFS test, which is like a conformance testing library. And most of the things that we saw, there were lots of passing and failing tests, but this was expected because of the nature of iRODS. It's different from what Linux and Unix are trying to accomplish. And the last thing is we want to, we plan to use NFSRODS as a reference for when we begin implementing support for Samba and CIFS. So thanks, and questions?
Oh, 3 hands, 4 hands. All right. Here comes Kory.
Okay.
Hi.
Hey.
I'm one of these sysadmin types whose hair caught on fire when I saw the no groups and the world permission stuff. But I'm not going to ask about that. You're trying to solve a specific problem. How do you, are you supporting hard and soft mounts? Is this just soft mounts?
So I don't have tons of knowledge about mount. I was given this project, and it's all these things I'm learning while implementing NFSRODS. So it's tricky to navigate and know what's happening at all times. So by all means, if you have, apparently it sounds like you know about hard and soft mounts, so you might be able to.
And POSIX file systems.
Yeah.
So yeah, maybe we'll be talking a bit later. Have you tested this with like the Windows Pro NFS? Or are you typically going after the SMB client market?
I have not tested it. The only thing we've tested with is the NFS test, which was mentioned here.
Okay. I'm also assuming ID-MAPD has gone by the wayside for this.
I did try to use ID-MAPD, but I ran into lots of issues, which led us to, what we have today.
And I guess the last question is, how are you handling nobody?
So we cache the IDs of nobody within NFSRODS, and basically when we're trying to produce the stat information, we're doing lots of verification steps in between this before we just assume that nobody owns this file, right? But essentially, if that is the case, then it will, you will see nobody for a file. Like if I remove John right now, then nobody would show up.
User nobody is handled though?
Yes.
Okay.
You're last.
Hey, you said it was a bit slower, the NFS. Could you give an indication how much slower it is than the I commands?
I do not have like a comparison of how much slower it is. This is more
A
so.
rough guess?
Oh, I can't even give you a rough guess. This is just more so because we've introduced a layer, and depending on what your network is like, you, as well as mount options and all those things, it could be slower. It probably will be slower.
Okay, thank you.
Hi there. How does it show up on the IES, so in an IPS output?
What was that?
So when you're on the IES and you use the IPS command to show connecting clients, how does it show up in that?
I have not tried that. I have not tried that. Okay. So what's the what is
Just
the IPS?
IPS, yeah.
Okay.
There it is. That's what you see.
Yeah.
Yeah, it does hold a persistent connection right now. We haven't done anything with
Right. Yeah.
pooling
This is implemented using jargon. So this is all of this is a Java based application.
0.8.
Looks really nice. Thank you. So on our network, we cannot control the UIDs. We cannot prevent root access. So the only way around it would be to prevent by IP address or something like that. Is the Kerberos support still intact?
We do still have the Kerberos implementation in a separate branch. We did not get rid of it, or better yet, it's still in history, right? Because this is in GitHub, so we could always bring it back and enhance it.
Well, I believe with NFS4 there's a couple of other authentication mechanisms, but I'm not an NFS expert. Would any of those be a solution?
Possibly. We know through talks with the Dcache team, who are the people behind the NFS4J project, that we know it has native support for Kerberos, but they never mention anything about any other ways to authenticate users. So, but I think we were looking into investigating PAM. I think that's one of the open issues for this type of thing. So.
All right, thank you.
All right. Thank you.